Okay, so today I'm just going to go over in more detail double replacement reactions and kind of what actually is happening in those reactions. And you're also going to be able to predict your products that you're forming in these reactions. So just to review, remember in double replacement reactions, we're actually swapping two elements from two different compounds. So in this case, I've basically taken this second element and I've swapped them, okay, or replaced them. So then over here, we can see that D is now next to A and B is now next to C. So we've just had two different elements that have swapped places. When we're talking about double replacement reactions, a lot of times what we're looking at to determine if this type of reaction has taken place is we're actually looking to see if we have this insoluble substance that's formed. So just need to make sure that we know that when we're talking about a soluble substance, we're talking about something that has dissolved into a solution. When we're talking about insoluble, we mean it has not dissolved. Okay, so it's basically like a solid is going to be found at the bottom of our mixture that we have. So we can kind of show, like if here I have a double replacement reaction, so I have potassium carbonate and magnesium nitrate. Okay, and what's happened is I just have, again, same thing, two different compounds, two elements in those two different compounds are swapping places. Okay, so the way that actually happens is we can see that here I have K2, so I have 2 potassiums, and then I have 1 carbonate in this first solution. Aqueous just means that it's dissolved in water. That's all that means. So when it's dissolved in water, it's actually going to split up into ions. So here with our next compound, I have 1 magnesium, and then I end up with 2 nitrates. So if I have these two different solutions, aqueous solutions, and I mix them together, what am I going to get? What's my product going to be? So what actually happens is my magnesium and my carbonate, right? So they've kind of different, they've swapped places. It used to be nitrate with my magnesium, now it's carbonate. And these actually form a solid down here on the bottom. And we can show that it's a solid by actually writing an S next to this compound. Up here in the top, we have an aqueous solution. So again, that just means dissolved. And when that happens, we are just seeing these ions that are separate. So we have the same ions that we had before, 2 potassiums and 2 nitrates, and they're just floating around a solution in this 1-to-1 ratio. So as we go through, this is just kind of review. Aqueous just means dissolved in water. If I end up with a solid, I'm actually going to call that a precipitate. Okay, so this is kind of the fancy chemistry word that we use for that solid that's produced by this chemical reaction. And the reason we gave it a fancy name is because it wasn't there to begin with. So I started with 2 liquids, or 2 aqueous solutions, and then I ended up with a solid at the end. So I call that a precipitate. We are going to be using this page in your lab manual. If you need to find that, if you need to just pause it and find that page in your lab manual. We're kind of down at the very bottom of the page. So we have basically some rules for how we can predict our products for our double replacement reactions. And then we have some solubility rules that actually can tell us if a precipitate is going to form or not. Okay, so remember, if it says soluble, okay, that means that everything is dissolved. I have aqueous solutions. If it says insoluble, that means I'm going to have some kind of precipitate or solid. So if you want to add that to your page, that's totally fine. And really, if we kind of look through these rules, almost everything is soluble. There's only a few things that are insoluble. So I actually go through and kind of underline my insolubles. So all hydroxides are insoluble except group 1, barium and strontium. So remember, group 1 is that first column in my periodic table, like potassium, sodium, lithium, those elements in that first column. Okay. And then let's see, what else can we find that's insoluble? So here it's talking about the borates, carbonates, chromates, oxates, phosphates, silicates, sulfites are insoluble, but we have an except. Okay, so this is important. Anytime these excepts are coming from these rules up here, like number 1. Okay, I've already been told that these are soluble, so I can't kind of go back on my rule. So we can't forget about the except rule. Okay. The very last thing are these sulfides are insoluble. And again, we have an except. Okay, so as long as I don't have one of those, I know that it's going to be aqueous. So I'll kind of show you what I mean as we go through, but you will be needing to use these rules kind of as we talk about it. And then these are just, again, the same rules. They're in the slides if you need to kind of look at those, but they're the same thing that's on your reference sheet. And then same thing, our solubility rules. We know that if it's soluble, we're going to use aqueous. If it's insoluble, we're going to use our S symbol for solid. Those are really the only two that we'll use for double replacement reactions. Okay, and again, this is kind of the same thing. It's just showing you that down here, this is where I have my precipitate at the bottom, and then this is my aqueous solution here. So aqueous, and then my solid for my precipitate. So here is one reaction. I'll post the actual slides to this too, so if you want to actually go back and watch this video. But what happens, since I saved this as a PDF, it's not going to play, but when I add these two things together, what I end up getting is this really pretty yellow substance at the end. And it actually is this kind of solid yellow substance. And I'll just write solid so you know. We know that a chemical reaction occurred because we had this color change, and we also had a precipitate form. So we know that there's some kind of reaction going on. So what's actually happening? So let's look at what's going to swap places in our reaction. So if I take my I and my nitrate and I swap them, right, I'm left with my K is in the same place, but now it's my nitrate is over here. Okay, then I'm left with lead, Pb, and iodine. But remember, we have to look at our charges to know how to write our formulas. So this is where you'll have to look at, I believe it's page 145 and 146. I think I put it in the lesson plan instructions. So I think it's page 145 and 146, but you'll look at their charges. So remember, potassium has a 1 plus. If I'm looking at my reference sheet, that page 145, it has nitrate has a 1 minus. So when they crisscross, it's just 1 and 1. So it's just KNO3 plus lead. Remember, this is a transition metal. It has multiple charge options. So how can I figure out my charge for lead? All I have to do is look down here beside my nitrate, because remember that 2 came from lead. So lead has a 2 plus, iodine has a 1 minus. So when they crisscross, I end up with PbI2. Okay, so now I'm just going to kind of scroll up so we can look at our solubility rules, because I want to know which one of these is going to be the solid that we produced in my reaction. So if I scroll up, and like I said, you can just be looking at your yellow sheet. So I know I have a nitrate. So if I'm looking for nitrates, then I can see that number 2 talks about how nitrates are soluble. Okay, so remember, soluble means I'm going to put that AQ next to my nitrate. Okay, but my last substance is that iodide. So if I look, number 3, it says bromides, chlorides, iodides are soluble except, right, lead. So since I have a lead iodide, that actually means that it's not going to be soluble. It'll be insoluble. So if I scroll back down, we said our nitrate was my AQ, and then it's this lead iodide that's actually going to be my precipitate. Okay, that's my insoluble substance. And so since it's insoluble, I designate that with an S next to it. That's that solid. So let's look at another example here. Okay, so here I have silver nitrate, sodium chloride. Okay, so if I know that my 2 things here are just going to swap places, I have a silver chloride plus sodium nitrate. Okay, so now I can look and see, okay, well, which one is, am I going to have a precipitate? Okay, and where is it going to be? So again, I'm going to scroll up here. Okay, so number 3, again, says all bromides, chlorides, iodides, so we have a chloride, are soluble except, and look, silver is one of my exceptions. So that means that silver, sorry for scrolling, silver chloride is going to be my solid, my precipitate. Okay, and then my rule about my nitrates means that these are going to be soluble or aqueous. I'm only ever going to have one precipitate. Only one precipitate. So you can kind of, once you find it, then you know the other one has to be aqueous. There is a possibility of having no precipitate, so don't get in the habit of accidentally finding the one that's soluble and then thinking the other one has to be a precipitate, because they may both be soluble. Okay, so here we can do another one, except for this one's a little different, because since it's hydrochloric acid, okay, I might have to actually write out my formula instead of just being able to swap my words. So silver nitrate plus, how do I write hydrochloric acid? I know it's an acid, so it has to start with an H. My ride has hydraulics, so chloride is just Cl. Okay, so if I look and I say, okay, well, I want this to swap with this one. Okay, so what am I left with? I'm left with my silvers in the same place, and now I have a Cl, plus my H is in the same place, but now I have nitrate. Okay, and luckily all these are 1 plus or 1 minus, so their charges are just going to cancel out basically once they crisscross. So don't have to worry about adding any subscripts. I do need to look and see which one is my precipitate. Okay, look and see for my precipitate. So without scrolling, you can just kind of glance at your rules. But again, I'm looking at that rule number 3. Okay, it's telling me that chlorides are soluble except for silver. So since I have this silver chloride, again, that's going to be my solid, my precipitate. And then my rule number 2 is the one that tells me my nitrate, right, is aqueous. Okay. So it might be a good idea to pause here if you want, and you can kind of try this one by yourself and kind of check your answer. Or if you want, I can give you the formulas if you want to wait till I write the formulas down. So sulfuric, right, ick, 8. I ate something icky, so that's going to be my sulfate, H2SO4, plus sodium, and then hydroxide is a polyatomic ion, OH. That's on your polyatomic ion list. Okay, so if I'm looking at swapping, right, I'm going to swap the ends with the ends. So I'm left with my H stays there, and then I have an OH, and then I have an Na in the same spot, and I have SO4. So I need to look at my charges. So I can crisscross correctly. So HOH, those charges are going to cancel out because they're ones, but how can I write HOH, which is in a more convenient way that we would recognize? It's the same thing as H2O. I have two H's and one O. And then here, my 2 is going to crisscross down. So I have Na2SO4. Okay, so now I can look and see, okay, well, do I have a solid here? Do I have a precipitate? What are some of my rules? So again, I'm not going to scroll, but if you go back to your rule sheet, if you look at number 7, it talks about sulfates. Number 1 also talks about group 1 compounds. So since sodium's in group 1 and it says it's soluble, that means it's going to be AQ. Okay, and then the H2O, we know that's not going to be a solid. It's actually just a liquid. It's just liquid water. So basically what we end up with is this salt, this sodium sulfate is just dissolved in water. Okay, so I don't have any precipitate in this one either. Okay, so I just want to show you how you can separate out your ions, kind of like the first picture that we saw, if this makes more sense to you, to kind of see it visually. Okay, so I know I have 1 copper, okay, Cu, and I know the charge is a 2 because of that number right there. And then I know that based on my formula, I have 2 NO3s. So then next, what I'm going to do is look at my next formula. So I have 2 sodiums and 1 SO4. Okay, so I've just kind of split up my ions. So this is what they actually look like in solution. They're all dissolved. So they're all broken apart. So now I need to look and see, okay, well, what are my products going to be? Well, if they're swapping, okay, and I have copper sulfate plus sodium nitrate, because all I've done is swap my last 2, and I look at my solubility rules. Okay. I can look and say, okay, well, let's see. Number 7 talks about sulfates, and it says they're soluble. It does have an accept, but none of the accepts are copper. So I know that this has to be aqueous. And then my nitrates, I know are soluble based on rule 2. So those are aqueous. So what does that mean? Well, that means that in my solution, it just looks basically just like my starting solutions looked like. Everything is dissolved. Nothing is a solid. Okay, so actually in this case, what we call it is, if I actually went into the lab and did this, I wouldn't see that nice, pretty color change or precipitate form. I actually wouldn't see anything happen because all of these are dissolved. It's going to look like just like when you dissolve salt into water. Can you see the salt that's dissolved? You cannot. So these are all dissolved. You can't really see what's in there. So what we actually say for this type of problem or equation is no reaction. Okay, so anytime you end up with an aqueous plus an aqueous, it's actually no reaction because we cannot see a precipitate. Okay, so our answer is always going to be no reaction anytime we have an aqueous plus an aqueous solution, just simply because we cannot see any kind of precipitate form. So there's actually no chemical reaction occurring. Those solutions are just staying dissolved and they're just mixing up. They're not actually reacting together. It's basically like you just created a mixture instead of a reaction. Okay, so just be kind of aware of that when you're looking at the homework module. If you have something that's an aqueous and aqueous, your answer is going to be no reaction. Okay, so unfortunately, you do have to go through and do the work first, just like we did here. But then your final answer, instead of being these two products, you would write no reaction. Okay, so once you finish watching the video, and kind of taken some notes and done, kind of work through some of the practice, you're going to do the homework module on double replacements, and then make sure here are the page numbers that I was talking about earlier. So in your lab manual, you might need to pull out these pages or turn to these pages as you're doing the homework. That'll kind of help you because it has the rules, and then this one is the charges sheet. I think it's page 146. That's the same page that's on the back of our periodic table that we use in the classroom. So it's the page that you're used to seeing. Same thing with the reference sheet. It's the same thing as the yellow sheet. It's just yours is white. So it's the same sheet that you're used to looking at in class. And then if you have any questions, be sure to email me. And then I will see you for our Google Meet this week.